Welcome to this video on finding the lowest common denominator, or LCD, of rational expressions. Let's begin. Remember, in order to add or subtract fractions, they have to have the same denominator. Let's take the example of 2 sevenths plus 4 sevenths. Well, what we can do is we can add the 2 and the 4 together, and we get 6 over 7. But what if we didn't have the same denominator? Let's look at another example. So for example, what if we had 2 sevenths plus 4 fifths? We cannot simply add across to get something like 6 over 12, right? Or even if we add the numerators together, we can't add the denominators together. So what do we have to do? Well, you might remember that what we do is we get a common denominator. So what we do is we say, well, 7 is a prime number and 5 is a prime number, and we need a common denominator. So over here, what is this denominator 5 missing? What value is it missing that 7 has? Well, it's missing a 7. Now remember, if you multiply by 7 over 7, well, 7 over 7 is just 1. And multiplying anything by 1 does not change the value of that number. So we can multiply by 7 over 7 without changing the value of our fraction. Okay, then what are we missing over here? Well, this guy has a 7, but he doesn't have a 5. He needs both numbers. So we can multiply by 5 over 5. Again, remember, 5 over 5 is just 1. Multiplying by 1 does not change anything. So what do we have? Well, 5 times 2 is 10. 5 times 7 is 35. Then we have 4 times 7, that's 28, again over 35. Now that we have found and achieved the common denominator, we can add across in the numerator. So 10 plus 28 is 38, and our denominator stays the same. So we get 38 over 35. I have some more basic videos on how to add and subtract fractions, so if this is frustrating or challenging for you, please find those videos or ask your instructor. Alright, so this is how we add fractions with just numbers, but what about polynomials? So in this example, we're asked to find the LCD for the rational expressions below. Notice these rational expressions now have not just numbers, but variables in them. So you can do this in a lot of different ways, but I want to show you how to think about and understand this problem. So 5x to the third y is really 5 times x times x times x times y. So you can think about 5 times x times x times x times y as the prime factorization of that denominator. Okay? Then we'll come over here. Well, we have 10. Well, 10, the prime factorization of 10 is 2 times 5. And then we have x squared, so that's 2x's. And then we have y to the fourth, so that's 4y's. Okay? And remember our LCD. When we build our LCD, we take basically one of everything. Okay? So both of these have a 5 in them. So our LCD also has to contain a 5. Okay? And we can kind of cross these out as we go. Okay, what else? Well, they both contain, it looks like, they both contain 2 x's. 1, 2, 3, 4. So we can have x times x. Okay, now this guy has an x as well, so we have to throw that in. Okay, what else? What about the y's? Well, this guy has 1 y, so we can put a y in there, right? And then this has 3 more y's. So we have 1, 2, 3. Okay, so what else are we missing? Well, I think the only thing we missed so far is the 2. He has to be part of the LCD as well. Okay, so my LCD is 10x to the third, y to the fourth. Okay, so that would be my LCD. Again, when you're building your LCD, you have to put the ingredients of both fractions into your LCD. So the least common denominator, our final answer is 10x to the third, y to the fourth. All right, let's do another example. Okay, this one's a little bit different. We have 7 over x squared plus 4x plus 3, and then we have 5 over x squared minus 1. So let's think about factoring our denominators. This is a trinomial, so one method we could use would be the AC method. Okay, when we factor it, we get x plus 1 times the quantity x plus 3. Okay, when we factor the other fraction, x squared minus 1 is a difference of 2 squares, so we get x plus 1 times, times x minus 1. All right, so let's think about building our LCD. Okay, so when we build our LCD, we can see that they both have an x plus 1. Okay, they both have it. We only need to write it once. Okay, then what else? Well, this guy has an x plus 3, so that has to be part of our LCD as well. And then this fraction has an x minus 1, so that has to go into our LCD as well. So our full LCD, the lowest common denominator, is x plus 1 quantity times x plus 3 quantity times x minus 1. And I would just say leave it in factored form. I don't need you to expand or multiply. All right, let's do another example. So this time, again, we have two trinomials instead of just one. So x squared plus 2x minus 3. Well, we can factor that as x plus 3 times x minus 1. Again, 4 is on the top. Okay, then we have x squared minus x minus 12. Oops. So then when we factor that, that's going to give us x minus 4 times x plus 3. Okay, so let's build our LCD. When we build our LCD, we see that they both have an x plus 3 in them. So we only need to write x plus 3 one time. We do not need to write it twice. Okay, this guy has an x minus 1, and this guy has an x minus 4. Okay, so that would be our final answer. All right, let's do another example. So let's think about this. We've done several examples that says, why do we go through the trouble of finding an LCD? Why is this so important? Well, the reason is because we want to be able to add and subtract rational expressions that have different denominators. Okay, so the blank here, it says you cannot add or subtract fractions unless they have the same denominator. Okay, if I don't have the same denominator, I cannot do anything. Okay, so right in the example of 1/2 plus 2/3, right, let's build our LCD. Well, they don't have anything in common, so the LCD is just this number, which is 2, times this number, which is 3, which is 6, right? So we need to make the denominator of both fractions 6 in order to accomplish our goal, which is to add them together. So, of course, we would multiply this by 2 over 2. We would multiply this by 3 over 3. We get 3/6 plus 4/6, which is 7 over 6. Okay, again, I can't add them unless I have the same denominator. Okay, likewise, if I have 1 over 6 plus 4 over 9, right, 6 and 9 are not the same. So how can I do this? Well, the first thing I want to think about is I want to think about doing prime factorizations of both my denominators. So 6 is 2 times 3. 9 is 3 times 3. So let's use the same procedure to build our least common denominator. Well, they both have a 3, so we're going to put a 3 in there. Okay? Then this guy has a 2, which the other guy doesn't have. And this guy has an extra 3, which the other guy doesn't have. So let's find our LCD. What is 3 times 2 times 3? Well, 3 times 2 is 6. 6 times 3 is 18. So the least common denominator would be 18. In order to accomplish that, I'd have to multiply this fraction by 3 over 3, and I'd have to multiply this fraction by 2 over 2. That would give me 3 over 18 plus 8 over 18, which would be 11 over 18. So that is why we spend all this trouble and effort and energy in finding the least common denominator. So in the next two examples, we're going to do something different. Not only are we going to find the LCD, but we're going to use this information to obtain the same denominator. So let's look at this first example. We have 5a over, well, 4. 4 is 2 times 2, so I have 2 times 2. B squared is b times b, and then I have c. Okay, then we have 3c over 6. Well, that's 2 times 3. A squared, that's a times a, times b. Okay, so let's build our LCD. Okay, so they both each have a 2, so we'll put a 2 in there. Okay, then this guy has a 2 that the other one doesn't have, so we'll throw him in there. This guy has a 3 that the other one doesn't have. We'll throw him here in there. And then we have some b's, it looks like. So let's see. We have one b here and here. So we write him once. And then it looks like we have another b right here that one of them has that the other one doesn't have. Okay. You might have noticed I sort of skipped over the a's, right? There are 2 a's here, so they have to go in, right? And then, of course, we need our c. Okay? So let's write out our LCD. 2 times 2 times 3 is 4 times 3 or 12. Okay, I'm going to go in alphabetical order here. A times A is A squared. B times B is B squared. And C is just C. Okay, so my LCD is 12A squared B squared C. Now, if we were doing some of the other practice problems, we would be done by now. But, oh no, what do we have to do? Well, the problem is we actually have to make, we have to force each fraction to have the same denominator. So let's think about what the left-hand fraction is missing. Well, this guy has a 3, so we need a 3 over here. We're going to multiply by 3 over 3. What else does this other guy have that he doesn't? Well, it has an a squared, right, or a times a. So we'll put that in there. Is there anything else? I don't see anything else that he has. So let's go in the other direction and let's look at what the left-hand fraction has that the right-hand does not. Well, the left-hand fraction has an extra 2. And what else? It has an extra b, and it has a c. Okay, so that's what the left-hand fraction has that the right-hand is missing. And if you don't believe me, if you're unsure about this, what you can do is you can just go ahead and multiply it and make sure that in each case you get the LCD. So in the numerator, we're going to multiply 5a times 3a squared. 5 times 3 is 15. A times a squared is a to the third. Now let's look at the denominator. We should have 2 times 2 times 3 times a squared times b squared times c. Okay, well that's the same as 12 a squared b squared c, which is exactly what we had for the denominator. Okay, let's look at the other fraction. Let's make sure that we did this one right as well. So we're going to multiply the numerator. We have 3 times 2, which is 6. Then we have 1b, and then we have c times c, which is c squared. Okay? Then in the bottom, we have 2 times 2 times 3 times a times b times b times c. Okay? Notice that is exactly the same as 6bc squared over 12a squared b squared c. Okay? Again, both fractions, okay, this would be our final answer here, these two fractions, have the same denominator. Okay? So again, the first part of this example is finding the LCD. The second part of this example is obtaining the LCD for both fractions. All right, let's do another example here. In example 2, you can see we have 5x over the quantity x squared minus 5x minus 6, and then we have x minus 2 over x squared plus 4x plus 3. So the first thing I'm going to do is I'm going to factor both denominators. So I can use the AC method if I want. This factors as x minus 6 times x plus 1. The other fraction factors x squared plus 4x plus 3 factors as x plus 3 times x plus 1. Okay, remember now we need to build our LCD. Well, let's see if they have anything in common. It looks to me like they both have an x plus 1. So remember, if they both have something, it only goes into our LCD just the one time, not twice. It only exists once. So we have an x plus 1 factor. Okay, then we have an x minus 6 over here. So we'll write x minus 6. Okay, and then over here, looks like we have x plus 3, so we'll write x plus 3. Okay, so already we're done. We have our LCD. Okay, so in order to obtain the same denominator in both fractions, we ask ourselves, well, what is each fraction missing from the LCD? And I tried to sort of color code this so that it's very obvious. So we can see that the left-hand fraction misses or is lacking x plus 3. Okay? The right-hand fraction is lacking the factor x minus 6. Okay? And I'm going to do something here real quick. I want to add parentheses around x minus 2 to remind you that we need to FOIL when we multiply those two terms. Okay? So just looking at this, hopefully you can see that we have obtained our LCD, right? Each fraction now has all three terms, has an x minus 6, right? They both have an x minus 6, they both have an x plus 1, they both have an x plus 3. Okay, so now what remains to do is to sort of expand our numerators. So let's see if we could do that. So we have 5x times the quantity x plus 3. So we could distribute this 5x, and we get 5x squared plus 15x. Okay, so that's going to be the numerator, okay, over, I'm just going to sort of do this in shorthand, divided by the LCD. I'll put it all together and show you the final answer in a second. Okay. Likewise, over here, we need to expand or FOIL x minus 2 times x minus 6. So if we're using FOIL, it's going to be x squared, first, outer, minus 6x, inner, minus 2x, last, plus 12. So we get x squared plus 8x plus 12, again, all over our LCD. Okay, so let's actually write our answers out. I have some space up here. So I have 5x squared plus 15x over the LCD. LCD is, what is it? X plus 1, x minus 6, x plus 3. Remember that the order doesn't matter, right? Because 3 times 2 is the same as 2 times 3. Multiplication is commutative. Okay, so that's our first one. I don't really have room next to it, so I'll just put it right below. The second fraction is x squared plus 8x plus 12 all over our LCD, which of course is x plus 1 times x minus 6 times x plus 3. Okay, so this is your second set of answers. Again, the first part of it asks you to just find the LCD. The second part of it asks you to change both fractions so that they have the same denominator.